What if we could collect sunlight 24 hours a day, rain or shine? What if a single power source could beam clean energy to any point on the planet, ending our dependence on fossil fuels forever? This isn't science fiction. It's the ambitious dream of space-based solar power, and it might just be the key to our sustainable future. Welcome to the Clean Energy Journey YouTube channel, where science meets sustainability. We share how green energy will save our planet in the future. The idea of harnessing the sun's power from orbit has been around for decades. First proposed by scientist Peter Glaser in the 1960s, it was a concept far ahead of its time, a vision waiting for technology to catch up. For a long time, traditional solar power has been our best bet, but it has its limits. The sun doesn't shine at night, clouds block its rays, and massive solar farms require vast amounts of land. Space-based solar power, or SBSP, bypasses all these problems. It envisions a future where our energy supply is constant, clean, and limitless. Today, thanks to breakthroughs in aerospace, robotics, and materials science, this incredible idea is moving from the pages of science fiction into the labs of the world's leading engineers. So, how exactly does this futuristic technology work? The concept is both elegant and audacious. It begins with enormous satellites, equipped with vast arrays of highly efficient solar panels, placed in a geostationary orbit about 36,000 kilometers above the Earth. At this altitude, they are bathed in sunlight nearly 24/7, unhindered by atmosphere, clouds, or nighttime. These satellites act as giant orbital power plants, continuously harvesting solar radiation. Once the sunlight is converted into electricity, the real magic begins. Instead of sending that power down a very, very long wire, the satellites convert it into high-frequency radio waves, specifically microwaves, or in some designs, a concentrated laser beam. This focused beam of energy is then transmitted wirelessly across space. Think of it like beaming Wi-Fi, but instead of data, you're sending gigawatts of pure power. On the ground, a massive receiving station, known as a rectenna, which is essentially a giant mesh antenna, captures these microwaves. The rectenna then safely and efficiently converts the microwave energy back into usable electricity, which is fed directly into the existing power grid. Of course, every conversion step from sunlight to DC electricity, to microwaves, and back to AC electricity involves some energy loss. Overcoming these efficiency hurdles is one of the key challenges, but the fundamental principle promises a revolutionary way to power our world. This grand vision is no longer just a concept on a whiteboard. It's being brought to life by remarkable technological advancements. One of the biggest hurdles has always been the sheer weight and cost of launching materials into orbit. However, the development of ultra-lightweight, flexible solar panels and modular designs is changing the game. These new arrays can be packed tightly for launch and then unfurled or assembled in space, creating collecting surfaces spanning several square kilometers. Robotic assembly and maintenance are crucial to this process. Fleets of autonomous robots would be responsible for building these colossal structures in orbit and performing repairs, a task far too dangerous and expensive for human astronauts. Precision is also paramount. To beam energy over thousands of kilometers without missing the target requires incredibly accurate technology. This is where phased array antennas come in. These sophisticated systems allow for the electronic steering of the microwave beam with pinpoint accuracy, ensuring the energy arrives exactly at the designated rectenna on the ground. These are not just theoretical ideas. Global institutions are actively investing in making this a reality. NASA has been studying the concept for years. Japan's space agency, JAXA, has successfully conducted ground-based tests of wireless power transmission, and a team at Caltech recently launched a test satellite that successfully demonstrated its ability to beam detectable power back to Earth. These projects signal a monumental shift. space solar power is officially an active, global scientific pursuit. The potential benefits of succeeding are nothing short of world-changing. First and foremost, space-based solar offers a continuous, uninterrupted power supply. Unlike terrestrial solar and wind, it provides baseload power, the steady, reliable energy required to keep our civilization running 24/7, something currently supplied mainly by fossil fuels and nuclear plants. A single large-scale SBSP satellite could generate as much power as a conventional nuclear power plant, capable of energizing an entire city. Furthermore, this energy would be completely clean, producing zero carbon emissions during operation and helping us combat climate change on a global scale. Perhaps one of the most transformative aspects is its ability to deliver power anywhere on Earth. A network of satellites could beam energy to remote villages, disaster-stricken areas, or military bases, completely bypassing the need for complex grid infrastructure. This could foster global energy independence, reducing geopolitical tensions that often revolve around access to oil and gas reserves. For the first time in history, energy could become a universally accessible resource, not one tied to geography or geology. SBSP represents a paradigm shift, a way to revolutionize how our civilization consumes, distributes, and even thinks about energy. However, we must balance this visionary optimism with a dose of realism. The path to a space-powered future is riddled with immense challenges, both technical and financial. The single greatest obstacle is the astronomical cost. Launching the sheer mass of materials required for even one full-scale satellite and building the ground-based antenna would cost tens of billions of dollars. While reusable rockets are helping, the initial investment remains a significant barrier for governments and private companies alike. Energy loss is another critical factor. The multiple conversion steps mean that only a fraction of the sunlight collected in space will ultimately reach the grid. Maximizing this end-to-end efficiency is a major engineering problem. Safety is also a primary concern for the public. The idea of a high-power microwave beam directed at Earth naturally raises questions about its effects on people, wildlife, and aircraft. Engineers are designing systems with numerous safeguards, including low power densities at the antenna, site comparable to the midday sun, and automatic shutoff mechanisms if the beam strays. Another major risk is orbital debris. The space around our planet is already crowded with defunct satellites and junk, and adding massive new structures increases the risk of collisions, which could create even more debris in a chain reaction. Finally, there is the public perception issue. Some fear that a technology capable of beaming gigawatts of power could be weaponized, creating a death ray in space. Overcoming this skepticism with transparency and demonstrable safety will be crucial for public acceptance. These challenges haven't stopped a new global competition from heating up. We are witnessing the dawn of a new space race. But this time, the prize isn't just national prestige, it's control over the future of global energy. Japan has long been a pioneer in this field, with JAXA aiming to have a demonstration project in orbit by the end of the decade. China has announced an even more ambitious roadmap, with plans for a megawatt-level testing facility by 2030, and a gigawatt-level commercial system by 2050. The European Space Agency, ESA, and the United Kingdom are also funding feasibility studies and developing their own concepts. In the United States, a combination of government and private efforts are pushing the technology forward. Beyond NASA's research and Caltech's successful Maple experiment, private firms are entering the fray, seeing a massive commercial opportunity. This international competition is a powerful driver of innovation. Just as the original moon race accelerated technological development in the 20th century, this race for space energy could unlock breakthroughs in robotics, materials, science, and clean power generation that will benefit all of humanity. The nation that first masters SBSP will not only secure its own energy future, but will also hold significant geopolitical influence in the 21st century. Answering the "so what" question reveals the profound economic and environmental implications of this technology. The falling cost of launch, driven almost single-handedly by reusable rockets like SpaceX's Falcon 9, is the single most important economic enabler. What once cost tens of thousands of dollars per kilogram to send to orbit is now an order of magnitude cheaper, making the construction of massive space structures financially viable for the first time. From an environmental perspective, SBSP offers a path to truly carbon-neutral baseload power. While the manufacturing and launch will have a carbon footprint, the operational lifetime of the satellites would provide decades of clean energy with a minimal physical footprint on Earth. The land required for a rectenna is significant, but the area underneath can be used for agriculture or other purposes. This technology also raises fascinating ethical questions that we must begin to address. Who owns the energy generated in space? Should it be controlled by the nations that deploy the satellites? Or should it be considered a global commons, a resource for all humanity? How do we ensure equitable access and prevent energy from becoming another tool of geopolitical leverage? These are not just technical questions, but philosophical ones that will require international cooperation and new legal frameworks to resolve. As with any disruptive technology, space-based solar power is surrounded by myths and misconceptions. One of the most common fears is that the microwave beams are dangerous. In reality, the proposed power density at the center of the beam would be strong but manageable, while at the edges of the rectenna and beyond, it would be far below internationally accepted safety limits, weaker, in fact, than the radiation from a cell phone. Another myth is that the technology will never be affordable. While the upfront costs are immense, proponents argue that once the infrastructure is in place, the energy itself is free, and the long-term cost could become competitive with other sources. Finally, there's the belief that terrestrial solar is simply better and cheaper. The truth is, SBSP isn't meant to replace ground-based renewables, but to complement them. It solves the intermittency problem, providing a constant stream of power when the sun isn't shining and the wind isn't blowing. So, what does the future hold? The journey from science fiction to reality is likely to be a long one, but the timeline is accelerating. We can expect to see more advanced demonstration missions throughout the late 2020s and early 2030s, proving the viability of key technologies at a larger scale. If these are successful, the first commercial operational systems could start coming online by the 2040s. Looking further ahead, imagine a future where a network of orbital power plants is fully integrated with a global smart grid, managed by AI to deliver power precisely where it's needed. This network could even support future innovations like quantum communication systems. We have to ask ourselves, could this be humanity's energy singularity, the moment we achieve a truly sustainable post-scarcity energy civilization? We began with a dream born in the 1960s, a dream of reaching beyond our atmosphere to capture the limitless energy of our star. Today, that dream is closer than ever to becoming a reality. The journey will be long and filled with challenges, but the potential reward a future powered by clean, abundant, and continuous energy is too great to ignore. The story of space-based solar power reminds us that sometimes the most audacious ideas are the ones that change the world. Clean energy doesn't just come from the sun, it comes from our imagination. What are your thoughts on harnessing power from space? Is it our best hope for a clean energy future, or an expensive distraction? Let us know in the comments below. And if you believe in a future powered by innovation, don't forget to like, subscribe, and share this video.